So what are the basic features of that? Work done by a conservative force in a closed path is 0. So what do you mean by this? It will be WC, you write it, integral of FC bar dot DL. Dot product here. So what do you mean by this? Integration in closed path. There are two types of integral. This is called like a line integral. Say some f into dx. So when I write like this, integration in closed path. Okay, this you write it dr bar. If you write only this much, so what does it mean? Integration along one specific direction. Here, if I write a circle like this, it's the integration in closed path. Integration in closed path here. This is called like a line integral. This is called like a closed contour integral. So that word you may get confused. I'm just putting integration in closed path here. So what is the one basic feature of conservative force? Work done by conservative force in a closed path is 0. What are the examples of conservative forces? Gravitational force. Gravitational force. So gravitational force, nothing but the weight will come into picture. So more properly, the weight of an object. Weight of an object. And next, what are other forces? The spring force. Already you have some idea of spring force. Then next, elastic forces. Then not all, only few electrostatic. Means electrostatic again you will have conservative as non-conservative forces. So therefore, all electrostatic forces need not be conservative. That when we enter into the chapter LCT maximum, there you'll come across that one. So time being, I'll just put electrostatic. Then magnetostatic. Okay, these are all come under category of the conservative force. These are the examples. So examples, what are that one? Gravitational force, spring force, elastic force. I think time being, these three forces is what we'll be discussing in our the present chapter. The present chapter.
Sir,
Uh,
just assume a piston, sir.
you wait. I'll explain the concept. I'll give example. Then you can clarify your doubt. I know that one. Huh? They just wait for some time. Well, let me introduce some concept. Okay, this is about the gravitational force, spring force, and the elastic force. Fine. Next, again, so what are the, just listen at the end of the concept, you can come into the picture, huh? Not at the beginning of concept. Any have doubt? Okay, just preserve it. Now, these are the examples, that one. So what is the, any mathematical way of finding out whether given force is a conservative force? This one. So here, curl of a mathematical operation, curl of f bar, if it is equal to 0, then f bar is a conservative force. So there's a one, what is that curl operation? We'll see in the, it's a mathematical, like how we have cross product, dot product, no? Like this, what happens, we do have an operator called like a curl operator. So curl of f bar, curl of f bar. So how we had a dot product, cross product, no? Similarly, what happened, the curl is also one mathematical operator, which is introduced to perform some many operations of which we are using to show that given force is a conservative. To show that the given force is a conservative. That one. And similarly, if a curl of f bar not equal to 0, F bar is non F bar is a non-conservative force. So there's one basic idea, like whether a given force is a conservative or non-conservative. This is a mathematical. When they give equation, no, this is the most easiest way of concluding things. This is the most easiest way for us. Then this is about the if they give equation, there's the one. So what do you mean by curl of F bar? How it will be? How that operation will be performed? I cap minus j cap. The expansion of that, it will be dou by dou x, dou by dou y, dou by dou z, fx, fy, fz. There's just only presentation. I'll give all the examples. Just only this a presentation. It's not something I'm not telling. Just I'm giving the basic idea. These are the different things. Then come for this one. Work done by conservative force in a closed path is zero. What are the? Let's take example. I will take the weight of the object. Already we know the potential idea. This one. The block is at point P1. This one. So what I do, I will shift it up. Then I will shift it down. So I'll move from, let's say that from A to B, again back to B to A. So here it is shifted up, then shifted down. So let this distance be h. As it moves from A to B, O will shift not on its own, external agent. An external agent will slowly move the block from A to B. An external agent slowly moves the block from A to B and back B to A. What is the work done by the gravity? So how the weight mg will act like this. In the first case, when it is moving from A to B, so we are bothered about not work done by external agent, work done by the gravity. So here external agent will be here external agent will be applying a force. Slowly, I'll write it word slowly. Slowly word is there, no, already is there. Yeah. Okay, let's ask now work done by the gravity, work done by mg when it moves from A to B. So what is mg? Shall I say it does negative work? Because as it moves from A to B, how mg is acting vertically down. What is the displacement? Vertically up. What is the angle between the force and the displacement? 180. So I'll write minus mgh. So what is the work done by gravity? The block is shifted from A to B minus mgh. Work done by the gravity when the block is shifted from B to A slowly. How mg will act? In the direction of displacement. In the direction of displacement. So therefore, so this will be hu, right? I think I'll better let me write here so that will be easy for you. What is the net work done by the weight? Is it a closed path? Are you seeing any closed path? What do you mean by closed path? Where you begin, you should come back to that initial point. It's there's no necessity that you should trace a path. So time being. So therefore, this should be equal to now work done from A to B. Sir, you took vertically. So why don't you take in some arbitrary direction? Okay, let's take that also. So this is the block A. So what I do is like I will take some arbitrary path. slowly. The external agent will slowly lift, and this is a path. That one. So then again, he will bring like this. So there's a path. This one. So what is the network done by the weight? Then also it will be 0. So are you seeing closed path? Yes, it is. So this is one basic idea of. So shall I put like this? This is a mathematical way. Work done from A to B, then B to A. It will be 0. Or you do one thing, sir. I'll move in some curved path. Then also will be 0. So what we can conclude here now. This is one classic example of the work done by the weight. Somebody asked a doubt. Yeah.
Sir. Sir,
Ah.
it's me, sir.
Okay. Okay. Yeah. Carry on.
Sir, assume a piston, sir, and such that the pressure above the piston is greater than pressure below the piston.
Okay. Fine.
Then,
Yeah.
then due to pressure difference, there will be some force exerted on the piston, right, sir?
Okay. First, tell me pressure force, conservative force, or non-conservative force.
Yes, that is my doubt, sir.
Pressure force is a conservative force. Sir. The fluid, no, it is a.
Yes.
It's a fluid. Force exerted by the fluid must be conservative.
Oh, okay, sir.
Yeah, that one. In fluid mechanics, we can get in detail.
Okay.
I
Thank you.
didn't introduce that fluid force. Fluid force is again molecular force only.
Okay.
Say we have moved it slowly to explain concept. Why I am moving slowly to explain concept? Because if I don't move slowly, what will happen? The kinetic energy should be brought into the picture. I'm more interested to learn this one. So this is one basic idea about the conservative force. Work done by conservative force in closed path will be 0. Means now, so here let's come to the very beautiful explanation I'm giving it. So a person, what happened, will release this block from certain height. These are very, very best examples what available in SC Verma. So now the same person, what will happen, he will release this block on an inclined plane. Then next he will bring a some curved track. So what is the height of this? Let h be the height. So once you get this, rest of everything we know, you can manage very systematically this one. So so what we do is, let me go for some. No. Nowhere the block should not lose contact. Yeah. So in all the 4 cases, the block is released from rest here. The block is here, it will arrive with a speed v1, v2. Of course, velocity will be different. This will be v4. So there's a 1, situation 2, 3, and 4. In all above 4 cases, block is released from rest. I'm just asking what will happen to the speed of the block when it reaches the bottom of the incline. We know directly, you know, so don't bother about anything work done. Directly get into the kinematics. So from kinematics, what you can write it here like here. V1 equal to root of 2gh. How much of height the block will descend? It is freely falling, no? It's a freely falling. So V1 should be equal to root of 2gh. Then what about here? What force will do work here? So let this be theta, mg sine theta. So here, second case, I'll use work energy theorem. I'll release from rest plus mg sine theta into x. What is the distance here? Let it be x2. Into x2 equal to mv2 square by 2. From the triangle, so what is sine theta? H by x2. So in place of x2 sine theta, what you can write? H. Look at this, x2 sine theta. So I'm replacing here mg in place of sine x2 sine theta x2. I'll replacing this one. So mv2 square by 2. So finally, what I'm getting, root of 2gh. You look at the one and first and second case. Actually, O does work, only component of it, mg sin theta. The other component will be acting perpendicular to incline. Normal contact, work done by that will be 0. So O will do work, only the component of weight does work here. Then when I calculate the work done, you can see things clearly now. So when I calculate the work done, the work is done by only component of it. No, so I got the same speed, that one. Similarly, what happened here also, if I write equation, if I solve it, I'll get it. So for what is the final conclusion? V1 equal to V2 equal to V3 equal to V4 equal to root of 2gh. So therefore, this shows that this gravitational force, shall I say conservative force, it is independent of the path. Look at the path 1, 2, 3. Are they same? What do you mean by path? See, you move from one point to another point. Then, shall I say you're moving in one path? So look at here, work done is independent of path. No? So this is one advantage with the conservative forces. So if they give problem for us, this will be, third one is very difficult for us. Because look at the mg sin theta will be variable. We have to integrate, we have to solve it. So it's very simple. It's telling that just how much decrease in potential energy, mgh, that should be equal to kinetic energy. That's what this equation is telling. So to minimize mathematics, the idea of this conservative force is brought here. So why, sir, you can ask me, sir, why you are bringing conservative force? Just to minimize, to eliminate mathematical part in solving numericals, we are bringing this, the concept of conservative force. That's all. No other purpose here. Later, the conservative force played very important role. From conservative force, we went into defining the potential energy. From potential energy, we brought the potential concept. Like that, the application went further. So the main purpose was first to minimize the mathematics. So here, this is one advantage what you are going to see, that one. Okay, got this idea, no? So here to solve this particular thing. So let's go for a generalized equation. So here what's happening? The mg sin theta or mg is what doing work, no? So according to the work energy theorem, work done by any force should be equal to change in kinetic energy. Work energy theorem. Then work done by conservative force. You see that as the block moves from position A to position B, what quantity has changed here? Potential energy increased or decreased? When it moves from B to A, potential energy got decreased, no? So look at and how mg will act. Mg will act vertically down. Or let's come for this. I'll give a very best example. I'll define this is h equal to 0. Now, what is the potential energy at A? 0. What is the potential energy at B? mgh. Now, when it is ascending, mg does positive work, no? When descending, mg does, when it is ascending, the weight does negative work. When it is descending, so when it is ascending, the weight does negative work. When it is ascending, the weight what happened does positive work. Okay, look at that. When the block moves from A to B, what is work done by mg? Negative. And what happened? Potential energy got increased. And similarly, when the block moves from B to A, the weight does positive work. Work done by the weight, positive. because mg is acting vertically down, displacement is vertically down. So the work done by the weight, positive. So what happened? Potential got decreased. So there's some relationship between the work done by conservative force and the change in potential. So how they're related? Shall I put minus delta U? This is what happens. So work done by conservative force equal to minus delta. A good example is what this particular diagram itself, what you are seeing. So work done by conservative force should be equal to minus delta U. Means here, what is the meaning of this? When conservative force, when a conservative force does positive work, potential energy, I'm writing in short potential energy decreases. Similarly, when conservative force does negative work, potential energy. Sir, how do you can say? The diagram itself shows no here. Say, I'm not just telling like some videos, their content in the book. I'm giving enough diagrams to analyze. At least through diagrams you analyze here. It's not that somewhere in the book I'm just coming and dumping, I'm asking you to remember. Nothing like that. We have good examples here. When you move or you take notebook, you just rise it up, then the weight does positive work, weight does negative work. You release the book to fall freely, the weight does positive work. Then gravitational potential we do define like this. So there's one basic nature of the conservative forces. Okay, got this one. Now let me equate 1 and 2. These two equations I'm going to equate here. So with this, what I'm getting is minus delta U equal to delta. What do you mean by delta U? Final minus initial. Delta K means Kf minus Ki. So this should be Ki plus Ui, Kf plus Uf. What is Ki plus Ui? Sum of potential plus kinetic should be mechanical energy. Sum of kinetic energy potential should be mechanical energy. So therefore, when conservative force does work, and what do you mean by symbol E? So I'll write it here. Conclusion. Initial mechanical energy equal to final mechanical energy. So therefore, when conservative force does work, what will happen to the mechanical energy? It remains constant. Because I got initial equal to final mechanical energy. So therefore, when a conservative force, anything, positive work or negative work, when a conservative force does work, mechanical energy remains constant. Overall mechanical energy, total mechanical energy, you write it. Total mechanical energy remains constant. So therefore, what is delta E? When conservative force does work, so what happened to delta E? Delta E will be 0. What will happen to potential energy? May change. Conservative force, it must change. Conservative force does work, it will be non-zero. Then what about the kinetic energy? Will change that one. So some examples what I'm just picking up here. Is it okay? No? So this is nothing but conservation of mechanical energy principle. Law of conservation of mechanical. Very important at many problems I'll be using this. So what is this basic idea? No, there's nothing but called a law of conservation of mechanical energy. So therefore, when you should conserve mechanical energy, when a system is acted upon by several forces, all types of forces, but only conservative force does work, then mechanical energy is said to be conserved. Got this? So let me write that principle. It's a law I'm telling. So I think all of you, what do you mean by law? It's over. You should not question further here. You should try to learn only how to use that law. That's all. There's no other way. And this is the basic governing principle for us in the physics, whether a given question correct or wrong, whether what happened, whether what you did right or wrong. So you can take help of this one. So there's nothing but when a conservative force does work, total mechanical remains constant. So there's nothing but law of conservation of mechanical energy. So what will happen to potential kinetic? They will change, but overall mechanical energy of the system remains same. Is that okay? No. So there's the thing that one. Now we have to just pick up. So I introduced to the idea of what conservative forces. So let's go for non-conservative forces. So what do you mean by